Okay, hello everyone. I wanted to create just an optional exercise for you guys to do. It's not homework, you don't have to do it, but I wanted to give you some challenges of writing an n by n zero matrix, writing some code to create an n by n identity matrix, and then trying to create an n by n permutation matrix, which is rows I and j. And the reason for this is that once you graduate from this class, most of the matrices you're going to be dealing with are much larger than 3 by 3, and so doing hand computations becomes really it becomes impossible, really. You could be dealing with like 2,000 by 2,000 matrices, right? So to be able to write some code and handle larger dimensional data is a good idea. So let's start with challenge number 1. We want to create an m by n zero matrix. So to do this, I might start by defining or creating just an n by 1 matrix, right, or a 1 by n matrix. That would be just a list of zeros. So one way to do that would be to say for I in range n, okay, so I would want to do L.append 0. And now if I print that, you'll see that I should get a 1 by n list full of zeros. And oh, I've defined n equals 3 in this case. Maybe we'll do n equals 4. And you see it's a length 4 list. And so let's say I want to make a 3 by 4 matrix. I just need to take 3 copies of that now. So then next I could say for I in, or maybe I'll say j in range m, I want to do what? Let's see. Maybe I'll make a second list that's empty at the start, call it m, and now I'm going to say m.append L. And now I'll print m. And it says m is not defined. Oh, so maybe I'll say m should be 3. So Python's nice because it gives us an error that hey dummy, you never defined what m was supposed to be, you just threw it in there. So okay, so this is m equals 3 and n equals 4, and I created a 3 by 4 matrix. And I guess now I just have to turn that into a matrix. So I can do print matrix of m. So that's one way to go about it. And maybe I don't need to actually print m and l anymore. So you can create a list of length 4 of zeros and then just tack 3 of those on, make that into a list, and then make the matrix out of that. That'd be one way of writing this. And then if you wanted to turn this into a function, okay, all you'd have to do is say def, and then this is, I guess, let's call it zmn for m by n zero matrix, or 0mn. 0mn. There we go. So I'm just defining a function name. I could call it whatever I want. The inputs are now just m and n. And then all I have to do is take what I've written and indent it so it's sitting inside of this function now. Okay. And I don't have to worry about the commented code, but I'll indent it anyways. And rather than print this, I'm going to return that matrix now. And so now I've defined this function, and I always like to comment my code like so. Like I'll put the function name, I write what the input is and what the output is. And that just helps me when I come back to check my code months later, I remember what the heck I was trying to do, or what I was hoping the function would do. So 0mn takes in integers m and n, and it spits out 0 matrix. That is m by n, so m by n 0 matrix. Okay, so that's my function, and now I type 0 sub mn, and maybe I won't make a 3 by 4 matrix, maybe I'll make a, I don't know, 10 by 11. Okay, you can check. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, and 11 columns. Maybe that's too big. Maybe I'll do 3 by 5 or 2 by 5. That'll be easier to check. Yeah, so 2 by 5 zero matrix. So that's challenge number 1. Now to do challenge number 2, take a minute and try and tackle it yourself, and then maybe once you're satisfied with what you've done, or you want to check your work, you get stuck, you can always just play this video and I'll walk you through challenge number 2. So I'm going to start with a list of lists that all contain 0. So to do that, I'm going to say for I in range n, I'm going to do something. Right now, if I just say for I in range n, print I, you can see that I'm going from 0, 1, 2, and 3. So I must have picked n equals 3 at this point, right? No, n equals 4. So n equals 4, I get 0, 1, 2, 3. So I'm going to do 4 things here, right? Or create a 4 by 4 list. So let's start with L is an empty list. And then for I in range n, I'm going to take L and I'm going to append an empty list to that. And then I'm going to run through another loop that says for j in range n, I'm going to take L sub I and I'm going to add to it a 0. And when I do this, you'll see, maybe I should now print L sub I, and then I'll print L sub I comma j, and you'll see how L is growing. And then when I'm all done, I will print L. Okay, so you can see that it's going through and it's populating a list. At the very end, it's adding all of four rows of zeros, basically, right? So that's what I've done so far. So if I do this, I go 0 through 1, and I create row 0, row 1, row 2, and row 3, and they're all zeros. But I want to make an identity matrix. So I want to make this entry here a 1, that entry a 1, that entry a 1, and that entry a 1. And so what you can think on what I'm doing is I'm going to say, okay, L sub 0, 0, I'm going to redefine that to be 1. So that when I print that, you see, okay, there's 1, 0, 0, 0. And then next I'm going to define L sub 1, 1, that other diagonal entry. I'm going to make that a 1 too. So now I've made 2 of these 1s. L sub 2, 2, that'll be equal to 1. That makes that entry 1. And finally, L sub 3, 3, I need to make that a 1. Okay, so that would be the long, slow way of doing it. I could also do the same step just using a for loop. I just say for, maybe I don't want to use I anymore. Maybe I'll say for index in range n, I'm going to just define L sub index, the II entry, or the index entry, set that equal to 1. And that does the exact same thing. And so this is a way to print out a 4x4 identity matrix, or I can make it now a 5x5. Nothing changes really. And of course I want to make it into a matrix, so I'll get rid of the list now and turn it into a matrix that's 5x5. And now that I've written this kind of like loose code, I can turn this into a function, and that way I've compiled the function and I can call it anytime I want. So I'm going to define a function now called identity matrix. Maybe I'll call it identity matrix. And the input is going to be just n, the size. And now I need to indent all these lines 1 tab over, because they're sitting inside of a function now. And rather than printing, I'm going to return that matrix. So the return is what the function is going to spit out. And so again, it's a good form to comment your code. So this is called identity matrix n, and its input is going to be an integer n, I guess a positive integer n. It doesn't make sense to have a negative by negative matrix. The output is n by n identity matrix. And of course, Cocalc already has a function built in to create an identity matrix, but I think it's good to see how you could do it yourself. And sometimes it's faster to just create a function yourself than it is to go looking for it somewhere in the literature. Okay, so there is my function, n by n identity matrix. And here's one other hint, is if you define a function and you can put, I think, n equals 3 in there, and what that's doing is it's saying that if you don't specify n, the default will be to just make a 3x3 matrix. So let me just try that. Yeah, so you can see here, that if I don't put anything in, it assumes it's a 3 by 3 matrix. If I change that to 4, then it'll create a 4 by 4 matrix. But then you can also just go back through and say, I want a 2 by 2 matrix. So now you can put in whatever you want, and if you don't put anything in, it's going to assume it's a 4 by 4 matrix. So that's another little neat thing about Sage, or Python in general. Okay, now that's the challenges 1 and 2. Challenge 3 says create an n by n permutation matrix that switches rows I and j. And so what I'm going to do is I'm going to go back and I'm going to steal my identity matrix code. Or no, I'm not going to steal it, I'm going to call it. Okay, so let's say that I want to make an n by n matrix that looks like a permutation. What I could do is the following. I could just say M is identity matrix of size 4. Okay. Okay, that's gonna let me print M. Okay. And now I want to switch rows I and j. Well, what are I and j? I don't know. Maybe I'll define I to be, I will be 2 and j will be 4. Okay. So now what I want to do is I want to take M, but I want to switch rows 2 and 4. So one way to do that is to is the following. I'm going to make a list L that is a list coming from M, and I don't know if this works or not, but I'm going to try it. So what I've done is I said make a list that is a copy of M, and I'm hoping now that what I can do is create another list. Let's call it, I don't know, I'll create a variable T. T is an empty list. But then what I'm going to do, no, T is a copy, let me say T is a copy of L. Print T. Okay, so this copying thing I'm doing is just because matrices and vectors are immutable objects in Cocalc, which means you can't change them. But if you create a copy of them, then it'll allow you to change it. So like, I guess the idea is like if I were to try and just say L equals M and then start changing L, it would actually be changing M, because if you just set L equal to M, that's really like pointing to M. It's not really creating a copy of it. So that's why I'm making this copy of M and this copy of L. Is I'm just trying to make sure that M still stays the identity matrix, but T will be something different. And so now all I want to do is I want to change T sub I, and I think I want to make it T sub I minus 1, so I'm changing T sub 1, which is the second row. I'm going to make that M or L sub j minus 1, so I'm making it equal to the j minus 1th row. And then I'm going to do the same thing, T sub j minus 1, I want to make that equal to L sub I minus 1. So that should be switching rows I and j in T. So now let me print T now. Okay, did that do that? Yes, so that did that, and now I just need to make that into a matrix. Okay, so you can see what I did. First I printed T, which was the identity matrix. Print. Okay. So what I did was I printed T right here, and then I didn't want to print T. I just wanted to print the matrix of T, which is the identity matrix, and then these two lines of code right there are just switching rows I and j, rows 2 and 4. And of course I had to shift down by 1 for the computer indexing. So that is one way to create a permutation matrix that just switches rows I and j. And maybe that's not the most elegant way, but that's one way to do it. And you notice that I was able to take advantage of code that I'd already written to create an n by n matrix, and I just created an n by n matrix and then started manipulating it. So now all I'm going to do is start putting this into a function. So I'm going to say def, and then maybe I'll call this a transposition matrix. And I hope Sage doesn't already have that built in. Maybe I'll just say trans. How about TM for transposition matrix? So TM for transposition matrix. I'll comment that. Just say TM equals transposition matrix. And then the inputs are going to be the integers ij and the size of the matrix n, and then the output is going to be the transposition matrix that switches rows I and row j. So now I'm just going to indent all of this, and I think there's a way to just take all this, all these functions, and I want to auto indent selected text. So it should indent right there. I don't need to print L anymore. I don't need to print T. I don't need to print matrix. All I need to do is that when I'm all done, I need to return the matrix T. So let me try that and compile it. So TM 2, 4, 2, 4, 5, right? Doesn't seem right. 2, 4, 5. Oh, because I need to put n there. So now there is a 5 by 5 matrix that switches rows 2 and 4. And here's a 5 by 5 matrix that switches rows 3 and 4. Maybe a 6 by 6 matrix where I switch rows 3 and 5, and so on. So there's one way to write some code that would solve challenge problem number 3. I'm going to get rid of the stuff that I commented out already. And again, it's always good form to comment your code. So TM IJN is going to take in inputs, integers I and j, or for rows you want to switch. And we'll just say integers I and j, I, j, and n. The output is an n by n matrix, permutation matrix, that switches rows I and j. Okay, so that's just me being kind of crazy and commenting code. So I remember what I'm going to do, what it does later. So there's a good example too. So sometimes I put that in my comments too. I might say example, and I'll say TM356, and maybe that's too big of an example, but I could do like 2, 3, 2, 3, 3, and then there's a good example of what the output would look like. So that would be that matrix there, and of course I'll probably just want to make it a list of lists to keep it in one line. So maybe I'll say this. The output would be matrix 1, 0, 0, 0, 0, 1, 0, 1, 0. Okay, so hopefully you're enjoying some of these coding challenges, and if you want any more, just ask me and I can create some more and show you how to solve them. Have a good day. Thanks. Bye.